welcome here in the room, and hopefully also some people on site. Working now? Okay. Then let's see. Yeah, this session about moving faster with Tricentis Data Integrity, essentially the solution in our portfolio that deals with verifying, testing large volumes of data. But then it's special again, because it's not the ordinary functional or process testing or even API testing. It's about verifying large volumes of data. And that's why people sometimes do not or have come from different backgrounds. And that's why, of course, my first question before coming to the data background is what kind of experience do you have with Tosca in general, with our test automation platform? Would you rate yourself an expert user, have seen it before, or never seen, never worked it before? Any? Okay. Okay. Yeah, some experience, just for the. Okay, cool. Okay, cool. Okay, so you have seen Tosca. That will help. This will help later on in the practical session of the workshop. Exactly the same. Okay. What about you, if I may ask? Okay. Cool. Oh wow, longer than me. So cool. Okay. So next over there. Yeah. Yeah. Indeed. Okay, yeah. Okay, cool. And down here, the first row? Yeah. Okay. But you have seen it before, or? Okay, 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 cool. I hope I have some experience. Okay, cool. All right, so most of the people, to summarize for those online who could probably not hear all the answers, most of the people have at least seen it. Some of us have really a lot of experience, can teach probably me some things, but it's good to have some background. Now, let's really move into the data space, in the data warehouse or data integration space. Any of you who has a background in that space, data warehousing, analytics, data integration, both from a testing but also from an maybe development point of view, just a yes or no would be sufficient. So no's. Here's a yes, okay, and in the second row, no. Okay. It's a yes, so it's a mix. It's a 50-50, I would say. Okay. Should be all right. And then experience goes a little bit in the same direction in SQL, because, of course, Tricentis is about automation, and we are claiming that we are always scriptless, which is completely true. But at some point and in some situations, one needs SQL, not for the course, not for the practical session this afternoon, but in general, it helps. So again, the quick question, any background in this technology or landscape, or not at all? Very little, okay, at least something. Same, okay, so you're twins, sort of. Okay. Okay, cool. Yeah, similar, okay. All right, and then last but one question, data stores, because it's not only about testing databases, as we will see in a minute, but also more and more people are storing their data in cloud data stores, data lakes, and others. Would any of you have a background in those, either file-based or databases? Not, okay. Okay. Yeah, okay. Yeah, okay, as a repository database. Yeah, okay, cool. Okay. That's really cool. So we will use AWS later on in the workshop. So that's quite nice. And then, yeah, there we go. last questions. The cloud data stores, because these are the ones that are the most common ones. Although, of course, Snowflake being a database, I try to put it pretty generic. Azure, AWS, Google, Snowflake, any no cloud stores. Okay, so let's see. Yeah, okay. This part of Azure, okay. All right, yeah, so mixed audience, but that's fine. So let's really conclude. Let's look at the agenda. And first of all, given that we have this heterogeneous background, I need to bore you for half an hour or so with a couple of slides, giving the background about the use cases, the typical scenarios for Tricentis Data Integrity, and then also in the second section explain a little bit how it is working, how it is designed, and then hopefully we will have the chance to spend half an hour, 40 minutes or so with a real workshop, creating a couple of test cases, running them, and especially looking at the results, because that's the interesting part. Now, the slide you see here, you might have seen before when you were in touch with Tricentis, maybe as part of a demo or in another meeting like this. Maybe Siegfried has used something like this in the earlier session he had as well. It's an overview about our products, a lot of stuff on there. For today, we will focus definitely on the end-to-end data testing capabilities, Tricentis Data Integrity. Nevertheless, it is important to understand that technically it is an extension to Tricentis Tosca. So it's built on the very same platform. It's using the same ideas, the same, everything is a test case or a test step at the end of the day. The same ideas of modules in the background that are the building blocks to out of which the test cases are created or the test steps, the idea of execution lists, and so on. All the concepts. There was someone you mentioned the DevOps integration. All this works the very same way it works for standard Tosca. There are, however, separate and specific functionalities that are relevant when it comes to verifying larger volumes of data. Now, of course, I don't want to kick off a philosophical discussion or a scientific discussion what a large volume is. A couple of data items are always involved. If you do some functional testing or test an order to cash process, for instance, then of course you have to deal with data. There is an order number, there is a customer ID, a shipping address, product numbers, product descriptions, etc. This is data. This is not the kind of data we are interested in. For Tricentis Data Integrity, it becomes, or the other way around, Tricentis Data Integrity becomes relevant really if there are larger volumes, 10,000 rows, 1 million rows, 1 billion rows in a table when we talk about tabular structures need to be verified and validated. That's the really space where Tricentis Data Integrity comes into picture. Now, to make this a little bit more tangible, I'd like to start with 3 examples from actual customers who have really used Tricentis Data Integrity to solve some major business problems. And so put yourselves in the shoes of a pharmaceutical company. In this case, I'm even allowed to mention the name. It's Pfizer. US-based pharma company. They are producing a vaccine. It's not a COVID vaccine, but still important vaccines. And as we all know, these vaccines need to be kept in a certain temperature range. Otherwise, they need to be thrown away. They become unusable. And of course, they are producing millions of these doses, and this means that they also need to maintain large refrigeration plants to keep those doses of the vaccine in a certain temperature range. And of course, for good reasons, the pharmaceutical industry is pretty much regulated. So they need to provide the respective regulator, the FDA in the US, with a complete evidence that each and every individual dose of this drug at each and every, of this vaccine at each and every point of time has been in this temperature range. So they need to combine the data from the cooling plants and the production plants and so on. And now just imagine something goes wrong in this data combination. Some data is manipulated in a way it is not supposed to be. Maybe the combination between a charge number of a vaccine and the ID of the cooling plant does not work. Then they just have to throw it away. And throwing it away means financial loss. So that's the first scenario. Next scenario, completely different industry, this time retail. And now put yourself in the shoes of a retailer who does realize their sales exclusively on the internet, so they don't have any shops where you can walk in. Their average turnover is about $3 million a day, and they use a Mongo database as backend for the website. For those of you who are a little bit familiar with Mongo, Mongo is a not only SQL database, you can essentially store everything you want in Mongo, so it's not just necessarily tables and columns as we know it from Oracle or SQL Server. Which has a lot of advantages, but which has the downside that the structure of these MongoDBs are easy to break. And exactly that happens to them. The website becomes unavailable for a couple of hours a day, several times a year, because something in the Mongo database went south, did not work as expected. Now again, do the math, a couple of hours per day, a couple of times per year, maybe $500,000 loss in revenue. You can do the math and see the impact. And finally, an industrial company in this case, they went through a series of mergers and acquisitions, which made them end up with 10 data warehouses, so 10 large databases that stores historical data. And of course, they needed to save some cost and they needed to make this more usable. And that's why they consolidated those 10 data warehouses into a single one. And they refined a complete new architecture. They redeveloped the data model. And to migrate the data from all these legacy environments into the new joint and common data warehouse, they used file transfers. It's surprisingly enough, but we are well in the 21st century, but still people are using a lot of transferring of CSV files or other files to exchange data. Good or bad, it is the way it is. So they had to test this. And they deployed or employed 20 people in testing those file transfers. And those 20 people managed to test about 100 data files per week. Not so bad. Trouble is, they had to test 10,000 files. Now again, a little bit of a calculation. 20 people, 100 files means per week, means 100 weeks, equivalent of 2 years. Not really a feasible period, or increase the number of people. But do you want to have 2,000 people file comparing? Probably also not the best idea. So that's the kind of business scenarios we are tackling with Tricentis Data Integrity. And I could continue. The bottom line is there is always a problem. There is always an impact with bad data. If some larger volumes of data are not correct, this will result in reports being wrong, decisions being made on the basis of these reports being bad ones, operational issues, regulated industries have to face fines. And also, one area that I really like and that I keep emphasizing is the machine learning and AI initiatives. This is mainly about predictive analysis or identifying patterns in data. And from a testing point of view, this is hard because it's predictive. You don't have an expected result. So what do you do as a tester without an expected result? That's tricky, and I don't. And we are still not there that we can test that we can really test this. But what we can do is we can address one really basic problem. There is a study of the Harvard University available that suggests that the average data scientist, that's the kind of people that are working in these initiatives, spends 60 to 70% of his or her time to fix the underlying data. So rather than being able to develop algorithms to really drive this machine learning and AI specific stuff, they are busy with fixing data, filling gaps, closing missing links, and this is of course a waste of brain power that nobody can afford. So that's the consequences, and I guess out of these examples you already grasped what the main use cases are, or what actually the main use case is. The main use case of Tricentis Data Integrity is verifying that the data in the analytical environments, in the data warehouses, but also going beyond in the data lakes, in the reporting applications, the Power BIs, the MicroStrategies, the Clicks, the Talents of the Tableau, of this world is correct. And it's not only a single item, there is always a lot of data that needs to be checked. So that's really 80% of our customers who are using Tricentis Data Integrity use it in that space. That's for sure. Nevertheless, if you think of some business applications that involve larger volumes of data, we have one of our customers from the insurance industry. They are providing commercial insurance to industrial operations. So they are insuring the entire plants, the machinery, the materials, all in there. And as you can imagine, if they have to collect an invoice or a billing statement, this involves a lot of data items, 40 to 50,000, as we have been told, data items. And if only a few of those data items are broken, are bad, the entire invoice will be wrong. So that's another use case. And then finally, modernization of the data infrastructure. What do we mean with this? A lot of people are migrating to Snowflake, or even if it's Oracle, they are migrating from Oracle on-premise to Oracle on cloud databases, or replace Snowflake by Google BigQuery or by Amazon Redshift. And as soon as there is data involved, as soon as data has to be migrated from the legacy in the to-be environments, this is another reasonable use case for Tricentis Data Integrity. So that's the biggest business background. And now moving a little bit into the from the why into the what and how. So far, often data testing is done in a way that our American colleagues like to describe as manually staring and comparing. Literally sitting in front of two big computer screens, having an Excel sheet on the left screen, having an Excel sheet on the right screen, and then watching a ping pong match or a very fast tennis match, switching from left to right. Of course, I'm overstating. Of course, you can also apply some advanced comparison with Excel sheets. But we just had yesterday a meeting with a bank here in Amsterdam, and they really confirmed, yes, we do the testing, we are doing the comparisons manually. We have built us some lookups in there, but essentially we do this manually. Now that's not sustainable. That doesn't scale. That's not efficient. You can only compare so many rows or columns, data fields in an Excel sheet manually. And to be honest, I don't think there are a lot of people out there who like this kind of task of manually steering. There are really better ways of spending the time. And that's why we brought up Tricentis Data Integrity, which really extends the capabilities of Tricentis Tosca. So all the functionalities that we have in the UI automation, in the API test automation, by capabilities to verify large volumes of data. And this way, we really can make sure that while the data travels through the different applications of an organization, is changed, is manipulated, we can test it. We can do it in an automated way, yeah, no surprise. But the automation here has a specific aspect. As you typically have to deal with a lot of tables, each of which has a lot of columns or a lot of files in your data lake. You have a lot of test objects typically. And that's why one of the aspects of automation is automatically generating the test cases. So not only automatically running them, automatically maybe updating them or maintaining them, but also generating the test cases. Unfortunately, during the workshop later on, we won't be able to focus too much on this aspect because it requires database connectivity, and I considered it too hard to set up. But this is really one of the key elements. And then the last point, of course, we are also mentioning this all over again with standard Tosca, the continuous testing aspect. But again, in the data space, that's especially important because a lot of people are telling us, yeah, we are running our projects and we are testing our projects, and then everything is fine and we are bringing it to production. Fine. But then things are changing. There are data constellations that change that they didn't take care of during the development phases. There are new product codes, new sales channels or so. So also in the data space, continuous testing is a must, if you like. Okay, so that was the big background. Now let's move a little bit to the how does it work, and lead over to the workshop part. Or it's a good place, I think, to pause to see if there are any questions from the audience, either here in the room or online. Any questions at this point? Nope.
I've had some real good workshops about Neil as well. So would you say that data integrity is also something you want to integrate in your pipeline?
Yes, absolutely. So I'm repeating the question. Yeah, repeating the question for the people online. Question was, do we want to, or do we considering to integrate data integrity testing into the pipeline? Definitely. So it's definitely one of our customers, Allianz. They are running the eye test cases during their nightly builds, and they are even updating. They are not even only running them, but they are even updating them. So they are reading the new table structures, new columns, etc. From their modeling tool in this case, update the test cases automatically, completely without any manual interference, then run them, and then depending on the outcome of the run, decide if the execution should, if the build process should continue or not. So yeah, it's definitely, that's the continuous aspect actually. That's important. All right, now the rest of the slides and also the workshop, the practical experience later on will deal with this most important use case, which is testing the data in the BI analytics and data warehouse ecosystems. Now, everybody that has worked with or for a larger organization has seen probably some of those, some version of this slide. We have on the left-hand side, we have our application ecosystems, our SAP systems, our Salesforce, our core banking, core insurance systems, whatever the production management systems, whatever the operational applications would be, where the data is being generated, where it is maintained, where new customers are entered in Salesforce and new products in SAP, and so on and so forth. And then typically the data is moved, or a subset of the data is moved into some sort of central data store. Here we use the term enterprise data warehouse and data lake. Some people call it Central Data Hub. In SAP, it would be SAP Business Warehouse. So one or the other or hybrid forms, lake houses is also becoming more and more common. Some sort of central data store with historical data. And that's exactly the difference. Here in the applications on the left-hand side, the data is persisted, yes, but there is no history being kept. And it's always specific data applicable to production, to materials, to customers. Here in the data warehouse, the integration, the combination of the data is happening, plus building up a history. And this means data needs to be changed. Data, first of all, it needs to be moved from one application, from one system to the other, and it needs to be changed. Simple example, let's assume you have two systems where you have some customer data in there, and you have the genders in both systems. And in the first system, you write an M for male, and F for female, and an D for diverse, maybe. And in the second system, you have 1 for male, 2 for female, and 0 for diverse. If you integrate this data, you need to harmonize it. You need to find a common term, either one of those or a completely new one, ABC, whatever. And this is one of the easiest examples of integration and harmonization that happens. And of course, there is a lot that can go wrong. There are tools which are supporting this, no doubt about it, and there are business rules and there are business analysts also not to be questioned, but there are also developers being involved, and developers may make mistakes. So data might end up wrong in the data lake or in the warehouse. Challenge is this data being wrong is typically only realized at the far right end of the slide, in the analytics ecosystem, in the reporting application. And then the trouble starts because, someone looks at the report and says, can't be, nope. 10 million revenue, I would love it, but we made $1 million per month. Can't be that we made 10 million all of a sudden. And then the trouble starts because then you have to start digging. Where did the problem occur? And this is really the time-consuming thing. And this is exactly what we are going to address. And we do this, and now is really the link to Tosca and the actual implementation in Tricentis Data Integrity. We do this by providing predefined test types. If you are familiar with Tosca, you can easily translate it into test case templates. And that's what it is technically. From an abstract or logical point of view, it's predefined test types. And those predefined test types, they come in 4, or they can be categorized, let's put it this way, 4 groups. The first group is related to verifying flat files, CSV files, JSON files, XML files, both from a structural and from a content point of view. Simplest example, you've got an interface agreement with a provider of a CSV file that you are going to load in your data warehouse, and this interface agreement says the file has to have 20 columns separated by, let's say, a semicolon. Now, one of the first tests that you may want to apply is verifying that there are indeed 20 columns, and not only for the header line and the first couple of rows you see in an editor, but let's assume the file has 500,000 rows. You want to make sure that each of these 500,000 rows has those 20 columns. So that's the first test type that we are providing. And this continues. You can check for data types of columns. A CSV file, you can write anything in every column. But if you have a column that's supposed to have only numeric values, there is a test type which lets you test this. And it goes on to data content checks, value range verifications, for instance. Imagine you know that the file has a currency column, and in this currency there is only euro as a valid currency, but nothing else. No US dollars, no British pound, no Indian rupees. There's a predefined test type, which is called value range verification. The tester provides it with the feasible value, the euro in this case, could be many, of course, and then the test kicks off and verifies this. Typically, and that's why the name pre-screening has been historically chosen, typically applied against files before they are being loaded into some data warehouse. But of course, they can also be used for verifying exported data that's being sent to a consumer. The second group of tests are typically already applied at database level, and doesn't really matter what kind of database it is. As long as it is accessible by means of an ODBC or a JDBC driver, then these tests can be applied. And these tests are essentially, technically they are called vital checks and field tests, two subversions if you like. These tests are essentially high-level verifications. You check whether the data in your target environment that you want to test is complete by simply counting the number of rows. Now, of course, you will not sit down and write an SQL statement and then compare it to the expected number of rows. This will be generated. Or if you are a little bit more thorough, you can compare the minimum, maximum values, averages, aggregated values, totals. You can also compare the value ranges. Going back to our currency example, let's assume you move data from one layer to the other and you do not apply any currency conversions. Then if you have in the source only euros, you also want to find only euros in the target. So that's the kind of test. They will not tell you ultimately that each and every field, each and every row of your system under test, of your database that you need to test, is correct. It's a plausibility check, a high-level check. Nevertheless, they are valid and they are reasonable because they are completely automated. You can completely automatically generate those test cases. You do not need to write any line of SQL, anything like this. There are, as I said, in the Tosca language, test case templates behind it that can be leveraged to create those test cases. Now, at some point, you need to be more thorough. It's not enough to know, yes, the number of rows, the number of elements in my system under test meets expectations. At some point, you need to verify that each individual field, each individual row and column, if it is a tabular structure, meets expectations. And this is accomplished by means of reconciliation tests, or as we call it technically, row-by-row comparison. Row-by-row comparison, as the name suggests, is meant to verify the data on the most granular, most detailed level possible by comparing it to the expected result. The expected result either being provided or being calculated on the fly, or being available from a previous version, for instance. If you do regression testing, then you have the previous version results. And of course, you want to make sure that for those parts that you haven't touched, the results remain the same. And this is exactly what can be achieved here. They work cross-technology. So what does it mean? You can compare data stored in a relational database, say in Oracle or SQL Server, against the content of a CSV file or more cloud-style files like Avro, Parquet, JSON. It supports OLAP cubes. It supports legacy technologies like COBOL copybooks when you are from a mainframe background. So these cross-technology comparisons are always possible. And that's the most powerful component, as you can imagine. as everything in life, it comes a little bit at a price. You have to put in a little bit more work to create those test cases. And nevertheless, you will get a lot out of them. And then lastly, finally, we have the testing of the analytics and BI applications of the reports, of the dashboards, of the stories, how they are called in some tools. And this comes twofold. First thing is everything that's happening on the UI level. Is the user able to log in? Does the report refresh? Does the user see only the reports or dashboards he or she is entitled to? That's all accomplished by means of UI testing, UI test automation, all in the same tool as Tricentis DI comes with all the Tosca capabilities. But then you also want to make sure that the data in these reports is correct. And what we do here is we retrieve the data from the report as it is shown, either by means of UI or API automation, and then we feed it back into a reconciliation test to be compared against a previous version or the actual expected result from the database. And this way, we are really able to support the data testing from an end-to-end point of view. So that's for the theory. And now where are we in times? Yeah, any questions? Something from the online population? Questions? No questions. All right. Any questions in the room? No. Then I would suggest let's move on to the workshop part. Yeah, we can skip this. And I think you all got Tosca installed on your laptops. So if you are interested, just open it. And the first thing we need to do is we need to, so let me know once you are, I think I can walk around and see if you've got it, if you got it open. It's still opening, I guess. Yeah, okay, then gives me a break and a chance to take a bit of water. Exactly. The first thing I would suggest is that you create a new workspace, just a new single-user workspace. Give it a name, whatever you like. You don't need to use any templates or so. Just create a new single-user workspace, and once this is done, we can take it from there. For the folks online, I already did this. So I called this workspace Sogeti QX Day, but you can call it whatever you want. And whenever you are there, we can take the next step. So let's see where we are. Okay, looks good. Okay, once we are there, the next step would be to import the data integrity subset. And the best way of doing is going to the data integrity folder, which everybody should see, hopefully in their workspaces. And then going to the import subset. And then on the C drive, under C, Tosca projects, Tosca Commander, I can bring this up here as well. So C drive, Tosca projects, Tosca Commander. There you should find the Tosca data integrity modules and samples subset. And this we need to import. Yeah, so give people worked. So just let us in the room. It's pretty easy. Just raise your hand or so if something does not work as expected. Okay, cool. And if we open this imported subset or the imported folder, we will see additional modules. This folder, and you will also see this DI templates folder and this DI samples and execution lists. Now, if you want to work with the wizards that we see if we go to a data integrity folder here in the ribbon, then you need to move the folders to a structure as it is shown here on my laptop. So there is the data integrity testing on top level, and then underneath there is the folder underscore DI sample tests and execution lists, the underscore DI templates, and the modules folder can be anywhere, it doesn't matter. But the important thing is that the DI templates folder is directly under the data integrity testing. If this does not work for some reason, that the moving of the folders, it's not a problem for the rest of this workshop. We are not going to use the wizards, but for the future, this is probably one of the most asked questions to our help desk. It does not work because I can't generate test cases. And the reason being that the folder structure is not the expected one. Okay. Okay, so it seems here we are good. What about, yeah, here it's also looking good. Yeah, excellent. All right. So that's all we needed to do. And then the last thing, and that's again just a recommendation, just create yourself some folder where you can put all the artifacts that we are working with, a DI folder under the data integrity testing, just by right-clicking and then create folder, pick the purple data integrity folder, give it some name. Again, I called it Sogeti QX Day, but you can give it any name, whatever you like. And if you have done this, just create a test cases folder. So again, right-click and then the light blue folder type with a test cases folder. That's all we are going to need. We are not putting things in execution lists or anything else for the purpose of this workshop. So really just the test cases folder. Okay. Now, obviously, we need access to some data for this for the purpose of this workshop, because we want to create test cases that are meant or that are used to compare data. And to do so, we will access an Amazon S3 bucket. And there are two options. What I did here is the first line contains the URL to the console of Amazon. And what you can do is you can use this username and password provided there, and that's the only time you need to type this at some point, to download a file which contains the access key and the secret access key. Obviously, the secret access key contains of so many characters, but it's Amazon, I can't change it. I can't change it. That there is very likely to make a mistake, and that's why if you go to this URL, open the console, log yourself in. I think this password is still manageable with the 12 or so characters. And then you will see, or we can do it in parallel on the screen, you will see a file, a bucket and a file which contains the access key and the secret key. And then you can download it, and then you have it. So that's the only part where we need to fiddle around a little bit. So let me make this a little bit smaller so you can still read this. Come on, go away. Okay. So I'm just going to do it. So, calling this link. Then I'm going to provide the username, so JT underscore TST, and the password. I have the luxury of being able to copy it. You have to do the typing. That's the only downside. Okay, and I think I can hit enter. And then you will find this S3 here, this recently visited. Yeah. Take it slow, we have time. And I used the largest possible zoom ratio that the editor provides. Could have put it in a PowerPoint, but forgot this. Works? Okay, cool. And then we're about there. No, not really. Probably a typo, because if other people manage. This should be automatically, because you hit the URL, and then the key is +3. Yeah, okay, it looks okay. +3 #UCNT ampersand WR bracket IGLV. Yeah, looks okay. So Jetty TST. It's not Suggested Test, Suggested TST. There we go. Okay, this was the only time we had to do this, so we should be all right. And once everybody is there, just click the S3 link, which will take you to an overview of the buckets. And I think I can move this up a little bit now. And then you will see one bucket that's called JTQXD. Don't get confused by the insufficient permission. It does only permissions. It does only mean that you are not allowed to upload any data, because we need to save some cost. So click on this bucket, and then you will see. Let me move this over here. Yeah, again, the Sogeti QXD. And then there is one file which is the AWS access key, this one, where my mouse is pointing in. And if you click this, then you can download it here. So there's a download button, and you can save it to your local disk. And this file contains then the access key and the secret access key, and then you can do the copy and pasting for the subsequent steps. That's the only way we had to do. Okay. So just save it to any place where that you can remember. And once we have done this, we can go back to Tosca and create our first test case. And the way we do this, what about the time? Yeah, we are well in time, all good. The way we do this, we want to do a row-by-row comparison. And obviously, we want to compare a couple of those files that are also in this bucket, CSV files, Avro files, etc., against each other. That's the idea. It's the easiest way. We don't need to worry about any database connections or anything else, any drivers. So we want to do this. And the easiest way of generating, of starting to create these test cases is to hit in the data integrity ribbon, which becomes visible when you move in the left panel to a purple DI folder. To hit the row-by-row comparison button and then just select the upper entry, the standard row-by-row comparison module, and this will create you, like this, an empty test case. Create you an empty test case. Everything. Pardon me? Yeah, exactly. That's the standard version that's most of the time used. The version below points to another wizard, but this applies only to cubes, so not to files, and that's why we go with the standard version. And we'll give you an empty test case. So if you open it, you will see there are a bunch of parameters. Obviously, for those of you who are deeper in Tosca, what happens, the corresponding module for the row-by-row comparison, which is stored in the modules section, has been grabbed. Yeah, here, so this row-by-row comparison, this module has been grabbed and literally dragged and dropped into a test case to create these test steps. And what we have to do now is we need to populate the test steps appropriately. And as we want to compare two files against each other, files which are stored in S3, we go to the files section of the source parameter, so like there. And I think we want to compare, let me look it up. Yeah, we want to compare an Avro file against, what did I want to do? Against another Avro file. Yeah, a file against itself, just for starters. Okay, so we go to the files section. We then find the different file types that we are supporting out of the box. One of them being Avro. It's a binary compressed format, which is not readable in an editor, so you wouldn't see a lot. So that's the file type we want to compare. It's stored in S3, so we go to the S3 section, and now we have to provide all the information that's mentioned here. So the access key and the secret access key can be found in the file you downloaded earlier, and especially the secret access key is the troublemaker because it's so long. If you type it, chances are that you will make a typo. And then you populate the remaining information. So the access credentials, the bucket name, so JTQXday, we saw this. The file, that's really a simple, very, very small test file, which is sitting directly underneath, at the roof of this bucket. It's called so JT_access test.avro. The provider name is AWS. and the region is EU West 1. That's where the bucket is stored. So this information you need to put there. And for those of you who are a little bit faster, we put the very same information also in the corresponding target section. So we are really starting with something essentially stupid. We are comparing a given file against itself. So we are not expecting any deviation, any difference, but we see it works. We see the connection works. We see we have everything set up all right. And this is also from a methodology point of view. Whenever I walk into a customer pilot or a customer project, this is the first thing I do. I compare some object, either a database query or a file against itself. I'm not expecting any errors, but I want to see if everything runs smoothly. So that's what we are populating, both on the source and target side. Same information at the target side. And then, you let me know in case there are any questions from the online population if they are struggling. Okay, cool. Just wanted to verify. And then, as we want to compare these two files on the most granular level, we need to identify a data element. If it was a tabular structure, it was a row. If it was a JSON structure, then it would be a key. In JSON, you have key-value pairs. Now, Avro is a bit similar to JSON. It's only a different storage format. So it's a key that we are providing, and the key in this case, it's called name. It contains some first name, last name, the file, some user information. So the key is called name. In this case, it's really an individual column or an individual value which you need to know. That's something when it comes to data testing where you need to have a little bit understanding of the system under test. Similar to if you do functional testing, then you also need to know what process you have to follow. And it's the same here. You need to understand the data model, and you need to understand the keys of your data objects. And as said, in this case, it's called name. And then the last thing we want to do is we want an error report to be generated, and the corresponding information. No, I don't even have this here. Let's skip this for the time being. So if you have populated all these, and let me just hide the do nothing so that we see what information we need. We need the S3 information. And we need the row key. That's all we need. And once we have this, we can execute this test case. So directly in the Scratchbook, just by right-clicking and run in Scratchbook, we can kick it off. And if we didn't do any mistakes, we should see the test case running. Works? Yeah, well, it's a very small file. If you look at this, data integrity executor, which has popped up for you as well, then you see in the second line from bottom, it's 313 bytes. So it's really small, but we don't want to waste our time watching this executor do its work. And you also see in the second line from top, it has two rows in source and 2 in target. So it's a small thing, but it's about the idea and about verifying. Okay, we can connect to S3, we can read the data, we can access the data. We type the key correctly, and so on and so forth. That's the only purpose of this very initial test.
Is there any log files or something?
Yes. You can switch an extended log in here. If in this data integrity executor status, no, here in the status window, in the small status window that you just clicked away. No, go to the task line. No, the other one. Yeah, exactly there. And if you go to tools, the tools menu, there is options. And there is show debug messages, and it would tell you if there were any problems. So there was, just for the benefit of the online audience, there was just a question if there is additional logging information available in case there is any issue, it did not work as expected. And yes, there is. If you go in this data integrity executor status window, which popped up and which you probably have, which probably disappeared when you clicked in Tosca Commander again, but you can bring it up. It's still in the task list here. Just click on it, bring it up, and if you go here in the tools menu, options, and you can select show debug messages, and it will give you additional information. There is not a lot of additional information in case it went well, but in case there was a problem, you can switch the debugging information on. And it will then tell you wrong password or something like this. Okay, so everybody got to this point? Yeah, I see people nodding. That's great. All right, then let's move on to the next case. And the next case was a cross-technology example. So what we want to do in the next case, we want to compare a CSV file. So CSV file, everybody can read, which is called nation.csv. It's again stored in our bucket, but this time in a folder which is called CSV files. So here in the access key, secret access key bucket name is the very same as you had before, but this time in the CSV file section. The file name is the folder name, CSV_files, and then / file name, and the remaining options are again the same. And now for a CSV file, we obviously have additional information that were not required for the ARO file. We need to provide a column separator, which in this case is a comma, simple comma, and there is, you don't need to worry about typing, there is a drop-down from which you can choose the comma here, or you can type the comma if you prefer, both work. Yeah, exactly. Yeah, but you need to copy it from the ARO to the CSV section, so you need to do a little bit more copying. This can be automated as well, but it's not the first. For a beginner's workshop, it's a bit difficult to use the more advanced capabilities. Typically, you would put the stuff in a so-called test sheet where we maintain all this metadata, like tables, passwords, files, etc. But then I would need to explain the idea of the test sheet, and we only have so much time, so that's a bit difficult. So, same Same thing. So either you hit the row by row comparison button again, or you just copy the test case that you created earlier. Sure.
I try to row by row comparison again, but
Yeah.
I don't get the same test case as the previous one. So that's a bit weird.
Okay. Yeah, you have no. It's the same. Go back. Yeah. Undo. Just undo. Yeah. It's the same. Now open it. You probably have chosen hide unused objects.
Yep.
There we go. And all the objects are unused. All the parameters are unused. Just again for the benefit of the online audience, the colleague just created or just clicked the row by row comparison again. The empty created another empty test case, and now he was wondering, why aren't there any parameters visible? There's just row key and general options, but no source and target. And the most likely reason, practically the only reason, is that in the view menu, on the view ribbon, the show do nothing was deselected or selected. And this removes all the unused parameter. This is beneficial if you have too many parameters in a test step and struggle to find the right one. But of course, it's not really helpful if you have an empty one and need to look for the parameters. So just if you click this, then the parameter will become visible. If you click it again, they will disappear. Okay. So this is the input on the source side. I need to move the mouse away. The important thing is, of course, the file name, the column separator, and importantly, this for CSV files, you can have different versions of row separators. In this case, it's the Unix style. The file has been created on a Unix or Linux machine. So there is the row separator is the Unix. There's also a drop-down where you can choose. And this is one of the most common errors people are struggling with. Again, they are saying, my row by row comparison is not working. It's complaining about number of columns not matching. Most likely, they have picked the wrong row separator. So options are Linux, Unix, Windows, Unix, or you can also choose your own. Of course, typically it is either Windows or Unix. So we have to select this. And lastly, as we are talking a CSV file, there may or may not be a column header. There may or may not be a first row that contains the column names. And that's why there is another parameter for the CSV file, which in this case the file does contain a header row, so we need to put this to true. And that's all we need to do. And then, once we have done this, I hope this is readable, it remains readable. You know the access key and the secret key, that's why I'm scrolling a little bit further up. And then we really want to do some cross-technology comparison, just to see how it works. Again, same bucket, same AWS instance, but this time we are not comparing to a CSV file, but to a Parquet file, another file type which is very common to cloud data stores. And again, a compressed version of the data. In this case, nation Parquet, so you already get the idea. It's nation data stored in CSV and nation data stored in Parquet. So we're using this file format. No additional parameters are required. And again, we need to know the row key, which we would identify by opening the file probably or getting from our modeling tool. And in this case, it's the nation key, n_nation key. And once we have entered this, we can again execute the test case, and it should work. So again, hitting the run button, run in Scratchbook, development interface, Tosca Commander goes to minimum, the data integrity executor, the other small window, kicks in, does the work. And it already tells us it's starting the row by row comparison. And of course, we have some network latencies, and that's why it takes a second. And here we go. Again, our comparison was successful. And now we already had 25 rows. So not only 2, as in the example before, but already 25. Of course, again, a very small amount, but a reasonable one. Just having a look. How is it going? Pardon me? Okay. What's the message? Okay. 0 target rows, 25. 0 target rows processed. Now something with your target is wrong. What's wrong with your target? Let's see. Okay. Is 3. Yep. In the target is not a CSV file, but a Parquet file, and you entered the information in the CSV section. So again, for those fellows online, another mistake that happens. The colleague was wondering that the comparison has not worked, but he picked as a target the wrong file type. So we, in this case, as a target, we picked a Parquet file, but he entered the information into the CSV section. Then, of course, it's different structures. The CSV reader isn't able to handle Parquet files, and it's complaining. Probably not the best error message, and would have been better if there was wrong file type or something like that. Interesting observation. I will take it with me and tell our engineers that they maybe improve this, but generally it is the case. Okay.
2003 to go.
Yeah, but it's only one. It's essentially only one. Okay. The others are very much the same, and we might not come to the last one. It doesn't matter. For those of you who are a little bit faster, you can already have a look at the third one. In this case, we are comparing now 2 CSV files against each other. So we are both times we are in the CSV section of S3, and we are comparing a file called claims CSV against a file called claims1 CSV. Other than that, again, comma as a column separator. The row separator in this case is Windows, which is the default. That's why I didn't have to select it. But if you do the copying from the previous one, of course you need to replace Unix by Windows. And other than that, it's just this information. And I think the row key, because it's not yet visible, is a column called customer. I don't think there is something to write here. Let me get away of this. So we have a little bit more room. Yeah, so the row key is customer.
So data integrity is it, training on the Tricentis Academy?
Yeah. But I suggest to wait. I suggest to wait for 2 weeks because it's currently completely redeveloped, leveraging all this new functionality because this has been added with the recent version. So direct access to the cloud data stores, etc. But there is, in general, a course which is called Data Integrity Specialist. It builds on the AS1. The automation specialist one, which teaches you the basics of Tosca, because you need to know what a test case is, what a module is, the basics, how to handle the user interface, etc. But once you have completed this, you can move into this DI course. No, we are comparing the entire content of the file, but we identify a row by the customer number. So let me open the file quickly so that we can have a look. I've got it here. So we are using this claims file. So the claims file has a wealth of columns, customer, whatever country, state, code, etc. And we are comparing all the values, but we need to know which row to compare against which row. Because we can't just the easiest way or the easiest way to think of this was to compare the first row in the first file against the first row of the second file. Second, third, and so on. But what if there is a different order? What if they are not ordered in the same way? Then you would result in an error, but the ordering might not matter. You don't care. You just want to have all your, in this file, I think it's like 10,000, 9,000, slightly more than 9,000 rows. You just want to have all the customer rows with all their attributes, but you don't care whether your first customer, the BU79786, is in the first row or in the hundreds or the 1,000 rows. And that's why we typically use a key, one or more columns, to identify a row. And then we match the source and target file, the first and the second file, by means of these keys.
If you can select it more row keys.
Absolutely. It's separated by semicolon. If you have multiple ones, if in this case the customer is unique, I picked a simple example to start with. But if you would need to add, I think there is somewhere, whatever the load date or some additional birth date or so, some additional attribute, you add it. Also, if there is no key, sometimes you don't have a key, then you can still work with all columns, and then it will do the comparison as well. So, and that's why we have to provide a key. Last thing I want also the report path. So if you scroll further down to the general options and the reporting, there is a parameter called report path. And I'm using a configuration parameter. You obviously don't need to do this. Just put a directory or a folder that exists on your machine, ctemp or something like that, where you have write access, and provide a name for the reporting file. I've picked CSV to CSV1, but you can, again, give it any name. Important thing, it needs to be an accessible path. So ctemp, we could quickly change it here. I was just a lazy guy and copied it from some other examples I had. So you could easily do something like, something like that, assuming there is a folder ctemp on your hard drive. If not, ctmp or differences between the source and the target, it will stop the comparison. that might be the desired behavior if you have 10 million rows and all of those 10 million rows have a problem in the data. You don't want to report 10 million errors. Nobody can read those. So there, stopping even after the first error might be a reasonable idea. We picked 100. But in our case, our file has, as we saw before, just slightly more than 9,000 rows. We want to see all the errors. So I've selected 10,000 as a parameter. And if we execute then this test case, we will see there will be a deviation. The test case will fail, and this time it's expected. It's supposed to fail. So, because these are the interesting pieces. Pardon me?
The report path. Is it the same for us?
Yeah, if you have a folder ctemp, can you check in the Windows Explorer if there is a folder ctemp? No, I don't see one. Then choose Tosca projects, that folder you have.
Yeah.
So there seems to be no ctemp folder. Probably this wouldn't work. Then choose the Tosca projects folder, some folder that works. Yeah. We're almost there. Once we run this test case, we can have a look at the error report, and then we almost made it. So I give you 2 more minutes to do this. If you succeed, perfect. If not, not a problem. We can still look at it here, and let me run it again. Yeah, the test case is supposed to fail. The first one, this one we created right now. Yeah, exactly. Yeah, it's supposed to fail, and it will give you, yeah, exactly, and it will point you to the error report. I can't see it. Not all were matched. Make sure, yeah. Comparison report created. There we go. Yeah, exactly. So just for those of you who have some challenge in the step, at some point it should, when you executed it, it should look something like this. The test case failed. It tells us here, if we look at the details in the log info, it tells us here 9,134 errors found. Some error details at the bottom, but the important thing is the comparison report created. And in this case, I wrote it to ctemp in my case, CSV to CSV1. And this error report will now contain all the differences in the file. And to read it, to open this error report, you have to open the report viewer. And the report viewer can be found in the installation directory of Tosca, program files xx86, Tricentis, Tosca Test Suite, Data Integrity, and then Tools. And then there is this report viewer, which you can start. And if you start it, it will, once it has started, it will come up here. So it will look like this. And you can then open this error report, either by dragging it from the File Explorer to this window or by browsing it. I'm picking the browse version. So I'm opening ctemp, and then we've got our error report here. The first one, CSV to CSV1. And if you open this, I'm doing it right now for the sake of time, but should work for you as well. It gives us all the details. It tells us how many source rows it has processed, how many target rows it has processed. It tells us how many errors it found. And it tells us, okay, there are 9,134 rows with differences in the data. Affected columns are the claim amount, the total claim amount, with data differences, and load date, it existed in the source, but not in the target. This column in our CSV file, if we go back here to the CSV file, you see the last column. It's due to the line breaks. It's on the 4th line here. Last column, load date, exists only in the source, so it's complaining. And the differences about the errors can then be found when going to the differences part. And we see here the claim amount in the source, we have 276.35. In the target, we have 276.35, and so on. So the decimal character got lost. That's an example, obviously, I made up. And we also have for the total claim amount, I think I built in another error in here. Yeah, here is the total claim amount. There I applied some rounding. So in the source we have 384.811. In the target we have 385. And the load date, you see it at the right end, is not visible at all. All the other values in the other columns match. So the policy type, policy, claim reason, sales channel, and so on match. And we can address this. It might be wanted, it might not be wanted. So the load date not being existing in the target, that might be okay, expected result. And we address this by excluding the load date from the comparison. That's the piece we are not going to make right now for time reasons. So here there is a parameter columns to exclude in our row by row comparison. And I picked the load date. So which means it won't care about the load date. Whatever is in there, if it exists or not, forget it, not to be tested. Also, for our rounding thing, the total claim amount, where I applied the rounding, I said, okay, I'm happy with a small difference. It doesn't matter. It's rounding. Just ignore it. So I'm applying a tolerance of minus 1% plus 1%. Could be an absolute value as well. And when I would execute this test case now, which I'm not going to do because we're on the top of the hour, it will not report these kind of deviations anymore. So it gives you a lot of flexibility in terms of comparing this. Yeah, and this brings us to the end of this workshop. Typically, you would do a lot more with databases. You would do a lot more cross-technology, slightly more complex cases. But I hope it gave an impression how it works in general, the DDI testing. Thank you for your attention.